Today's video is going to focus on short-run behavior. Short-run behavior is going to focus more on what's going on vertically, what's going on with my vertical asymptotes as opposed to my horizontal asymptotes. Before we begin the new, we're going to review what we did the day before. So the first problem we're going to look at is 12 over x minus 2 times x plus 1. The long-run behavior, if I were to FOIL this out, I get an x squared. So it would look like 12 over x squared, which would look like a 1 over x squared. And we know that 1 over x squareds kind of do the whole volcano thing. So if I'm looking at the long run behavior, I notice to the left and the right, they're going to be above my horizontal asymptote y equals 0. So yesterday we wrote as x went off to the right, it was above 0, we put a plus. As x goes off to the left, it was also above 0. Today we're going to focus on what's going on inside. We're going to talk about the asymptotes. Now remember, asymptotes are going to occur where this would equal 0. So what would make x minus 2 be 0? 2. So I'm going to have a vertical asymptote at positive 2. What would make this equal 0? A negative 1. So I'm also going to have a vertical asymptote at negative 1. So what we're going to do is we're going to look at each of these separately and see what our graph is going to look like. So we're going to start off by looking at the vertical asymptote of 2. So I went ahead and drew in and sketched in a picture at x equals 2. Notice my long-range behavior is still here. So when you're trying to figure out what's going to happen at this vertical asymptote, you're going to take this 2 and you're going to plug it in to the one that doesn't have the 2. Okay? So I'm not going to plug it into this because it would be 0. I'm going to plug it into the other one. And 2 plus 1 would give me 3. And 12 over 3 gives me 4. So along this vertical asymptote, it's going to look a lot like a 1 over x, which means, remember 1 over x's and how they look. 1 over x's look like this. They go up on the right, down on the left. So I'm going to go up on the right of 2 and down on the left of 2. So as x approaches 2 from the left, we're going to go down, negative infinity. As x approaches 2 from the right, we're going to go up. That's the first part. Now we're going to go look at the negative 1. What happens when x is negative 1? So it's the same kind of steps. I'm going to come over here to this equation, and I'm going to plug the negative 1 into the side that doesn't have the 1, because this would give me 0. So negative 1 minus 2 is negative 3, and 12 over negative 3 is going to give me negative 4. So the vertical asymptote of negative 1 is going to behave a lot like negative 4 over x or negative 1 over x. So it's going to behave a lot like where it's going to go up on the left and down on the right. It's going to do the opposite. Okay, so I'm going to go up on the left, down on the right. So as x approaches negative 1 from the left, we went up to positive infinity. As x approached negative 1 from the right, we went down to negative infinity. So up and down. So far we got a graph that kind of looks like this over here, and this over here. Then we have this little piece right inside. So let's go look at the final product for this one. So our final product, our summary of what this graph is going to look like, is we're going to have it going like a volcano at the top, and then we've got this little upside down parabola down here. And then they're going to want to know about all of our behaviors. So our long run behavior, left and right. As x goes off to infinity, we're above 0. As x goes off to negative infinity, I'm still above 0. Now I'm going to look at my two short-run behaviors. As x approaches negative 1 from the left, we went up. As x approached negative 1 from the right, we went down. Now we're going to go approach 2. As x approaches 2 on the left, we went down. As x approaches 2 on the right, we went up. This is neither even nor odd. It can't be folded on the y and be equal, and it can't be folded across the origin. And then we're going to look at our intercepts. Notice that I never touch the x-axis, so I have no x-intercepts. I do touch the y-axis. So in order to find the y-intercept, we have to remember our algebra. Algebra says to find the y-intercept, you have to let x equal 0. So I would come up here to my original equation, and I'm going to let x equal 0. So we're going to have y equals 12 over 0 minus 2 is negative 2. 0 plus 1 is 1. 12 over negative 2 times 1 is negative 2, which is negative 6. So my y-intercept is 0, negative 6. So these problems take a lot more work. Start with your long run behavior and then focus on each one of your asymptotes separately. Okay, let's pause that for a second. All right, well, the next problem we're going to look at, we're going to do the whole thing. 2x squared minus 2 over x plus 3 times x minus 1. So if we go back to what we did with long range behavior, I need to take the ratio of the top and the bottom, and if they happen to be the same, then I'm going to have to go divide. So if I go and I FOIL out the bottom, we're going to end up, if I FOIL right here, with x squared plus 2x minus 3. Notice that these are the same, so we're going to go and do some long division. So x squared plus 2x minus 3 into 2x squared minus 2. So 1 will go into 2 times. So it's going to give me 2x squared plus 4x minus 6. And then we're going to subtract. So the 2x squareds will cancel. I have 0 x's minus 4 x's. So I have a negative 4x. And I'm going to bring down. I have a negative 2 minus a negative 6. And negative 2 minus a negative 6 is a positive 4. Okay, remember, this is my remainder. So I have negative 4x plus 4 over x squared plus 2x minus 3 plus 2. Now I do my ratio. And if I do my ratio, I have negative 4x over x squared. So this is going to look like a negative 4 over x plus 2. So that's what this is going to look like. So all that tells me right now is when I go do my graph, is that I'm going to have a horizontal asymptote at 2. And because it's a negative 1 over x, my end behavior says I'm going to be below on the right and above on the left. So that's what I figured out so far. So they like us to always write our end behavior statement. So the long run behavior. As x approaches infinity, the function is going to be below positive 2. And as x approaches negative infinity, the function is going to be above positive 2. Okay, so that was what we did the day before. Now we're going to go do the new piece. The new piece is going to be to add our vertical asymptotes. So I'm going to go back to the original equation. My original equation said f of x equals 2x squared minus 2 over x plus 3, x minus 1. I need to go ahead and factor the top. So I factor out a 2 and I get 2x squared minus 1 over x plus 3, x minus 1. And then I can factor the top again. I get 2x plus 1, x minus 1 over x plus 3, x minus 1. Okay, so something happened here, something that hasn't happened before. You'll notice that the x minus 1 and the x minus 1 are going to cancel. And when that happens, it's called that we're going to have a point of discontinuity. We're going to have a hole in our graph where x equals 1. So those are going to cancel, but I have to remember, so when I come back up here to my graph, where an x equals 1, I'm going to have a hole. So what would the y value be if x equals 1? So we have to go figure that out. So 1 plus 1 is 2, times 2 is 4, so I have a 4 on the top. 1 plus 3 is 4. So I'm going to have a hole at 1, 1. So right here on my graph, I'm going to go ahead and put that. I'm going to have a hole at 1, 1. That's my point of discontinuity. Okay? So I have a hole at 1, 1. I'm below the horizontal asymptote on the right, and I'm above it on the left. Now I'm going to go focus on my vertical asymptote. So I know my vertical asymptote is going to be at negative 3. So 1, 2, 3, dot, dot, dot. And I'm trying to figure out what's going to happen to my graph at negative 3. Am I going to go up on the right, or am I going to go down on the right? That's what I'm trying to figure out here. So what we're going to do is we're going to look at the ratio and see what this guy's going to look like. And we're going to see that we have x plus 3 over x plus 1. So we're going to have to do some division again. Okay, so I'm going to take what I have left here and I'm going to do some long division. So the top is going to be x plus 3 will go into 2x plus 2. So how many times will x go into 2? It'll go 2 times. 2 times x is 2x, 2 times 3 is 6, and then we're going to do some subtraction, and I'm going to get negative 4. So short term, it's going to look like negative 4 over x plus 3 plus 2. Okay, so negative 4 over that would be y equals negative 4 over x. And because it's a negative, instead of going up on the right, I'm going to go down on the right. So I know that I'm going to go down on the right of the asymptote, and I'm going to go up on the left of the asymptote. So when I go sketch my picture, it's going to go all the way to the hole, and then on the other side of it, and then it's going to just go like that. So that's my long and my short range behavior. The last thing that they're probably going to do on the worksheet is they're going to give you a short run and a long run behavior and see if you can figure out what's going on. So I know this is hard to read. But they're saying the long run behavior, as x goes off to positive infinity, approaches 3 from a negative, and it approaches 3 from a positive on the left. So if I were going to draw this, the first thing I would remember is long range behavior tells me my horizontal asymptote. So I know I'm going to have a horizontal at 3. Then I would remember, because it says that we're going in the positive direction, that's on the right side over here, and it's got a little negative, so I know my end behavior is telling me it's going to be below. And this says if I go into the negative direction, which is the left side, then I'm going to have a little plus up there, which means I'm going to be above it. So I know I'm looking for a graph that does this to the left and the right. They tell me my short run behavior is around negative 1, which means I have a vertical asymptote at negative 1. And they tell me that as I approach it from the left, that's what the negative means, I'm going to positive infinity. So the left is going up. And it says as I approach it from the right, that's what the plus means, I'm going to negative infinity, which means I'm going down. So I would be looking for a graph that looks like that. And they wanted us to also write an equation. So y equals, because I had a intercept at 3, a horizontal at 3, I would put a plus 3. It looks like a 1 over x, but it's flipped, so I would have a negative 1 over, I went to the left 1, so I would put plus 1. And that's just one of probably several equations that you could come up with. The next video is going to actually go through the short run behavior worksheet and do some problems with you. So if you want to watch the next one, feel free.